On my birthday last year, we put out this announcement that we're basically pulling the plug on that platform, so there we go. So as I say, as far as today's talk goes, I thought, well, I'm going to be exhausted, but I don't want to talk too much about anything really. And dragging Chris in seemed like a really good idea. So talk, as I say, about how we became involved in Erlang in the first place, the role of big data, and the role that it has to play in, the role that Erlang has to play in with respect to big data and so forth. But first up, what I want to do is talk a little bit about, as I say, how we became involved in Erlang in the first place, and the work I did porting it and some of the challenges we faced doing that. Erlang's an appreciable code base, it's well written code, but porting it to alien platforms presents some interesting challenges. So, what significant event, now Stephen, who remembers all these funny dates and so on and so forth, is bound to tell us, what momentous occasion is the 4th of November 2008?
I keep losing you.
Sorry, Chris?
I keep losing you.
Oh, okay, I'm sorry, I'll stand close to the microphone. So I was just saying to Stephen, who seems to have who has a good memory for these things, you know, what momentous occasion, apart from us getting lecherously drunk, occurred on the 4th of November 2008? Well, what happened was Obama was elected. That was one thing. The other thing is that Chris and I were on assignment. We were in a little town called Folsom in California, which is about a 40 minutes drive from Sacramento. And we decided that we would save the company some money. Chris had a rental car, but we discovered that it cost like about $2 or something to get on the light rail and go into Sacramento from Folsom. It's about a 40-minute train ride.
Still losing you.
Oh, is that better, Chris? No, we can hear you fine. Can you hear me, Chris?
I can't now, but I keep losing you, brother. I don't think it's because you're moving away from my...
Okay, well look, we can hear you fine, so I'll keep talking and hopefully everything will come right with the world. But anyway, so we decided that this particular evening that we would save HP some money and we would take the light rail into Sacramento, and we went to the old part of Sacramento and had a lovely dinner on a paddle steamer. The paddle steamer just sits there in the water and floats like paddle steamers do, and Chris had a tuna steak and so on and so forth. And I think Chris has dropped out, but hopefully he'll come back.
No, can you hear me?
Yeah, no trouble.
I've lost the picture, the thing did drop, sorry.
Okay. Well, we'll leave it without picture for a minute, that might work better. Can you hear me, Chris?
Yes.
Anyway, I'll keep talking and hopefully the thing will sort itself out. Alright, anyway, so cut a long story short, so we got to Sacramento, everything's fine and dandy. We had a lovely meal there on this paddle steamer that just sort of sits there and blobs up and down in the water on the river. And I suppose it was about dusk. And we decided that, you know, we'd better head back to our hotel in Folsom. And we wandered up to where the train departed from, and there were these individuals sort of standing around, and this individual came up to us and started trying to flog us train tickets for a higher price than what you would actually get them out of the machine for. That was alright, that was fine. We didn't buy one.
Brett, I think you should point out that the machine was roughly 2 feet away from as well.
Yes, so not necessarily the brightest of salespeople there. Anyway, so we got on the light rail, and that was fine. And then we noticed these individuals exchanging these packages of strange white substances with one another and things like that. And they seemed very sort of self-confident, and that they were going to take over the world, and everything was going to be well and good. And Chris and I sort of sat there largely in silence for about 40 minutes, wondering when these people were going to get off the train. You know, we're looking out the window, we're looking at each other, we're just not making eye contact with them, because it really did not seem safe. Eventually we got to a point of relative safety and well, actually we got to the end of the bloody line. The train stopped before it got back to where we wanted to go, so we didn't have any choice, we just had to get off at that point. And we thought, well, what are we going to do? We're in the middle of nowhere, it's Friday night, literally in the middle of nowhere in the United States. The only thing around was like some little store that sold petrol and various other things and groceries and so forth, and it was about to shut. We called a taxi never arrived, didn't know what to do. We discovered there was another train. Anyway, while we were standing around and so forth, this sorry, Chris.
I think we found a shop called the Taxi, but we were standing around for about an hour.
We were standing around for about an hour and our phones were running down to about 0 on battery because we hadn't taken the liberty of charging them before we headed out. And while we were standing there on this corner, the good old boys were driving around, and like Chris will tell you, he's convinced that they had shotguns on the back of their flat decks, and they seemed quite intrigued by us standing there on this corner. So we didn't feel terribly safe in the middle of the US outback with all this nonsense going on. We then came to the realisation that we could get another train, even though we didn't have a ticket, we thought we'd try our luck. We came to this realisation we could get another train to another hotel. So we went and sat there and waited for it, and we'd noticed off in the distance there was a strange individual wandering around, wearing this incredibly bright orange bandana. And we thought, oh, nothing on it, whatever. Anyway, he wandered over and sat down beside us and started rolling up a joint, and offered the joint to us. No, that's fine, thank you very much. All good stuff. This chap reeked of cologne. Anyway, he then started explaining to us that in this particular hotel he had a pile of girls, all aged about 18. They've just got a new one in today that they call Pamela Anderson. This guy was a pimp. Oh dear. What have we got into now? So we've had the good old boys, we've had the drug dealers, we've got the pimp. But he was very friendly, as you'd expect a pimp to be, and that's fine and dandy.
Oh, but he did want us to go visit some of these girls.
Oh, he was really quite confident that he would get some business out of us. We just wanted to get back to the hotel. But anyway, he did help us to some degree. We got to this other hotel somewhere or other, and they kindly called us a taxi, and we got back to what was called the Lake October Inn where we were staying. Phew, and it had been a bit of a long day, so Chris and I sort of sat there and started talking. And the next few slides sort of cover it in more detail, Chris, but the net result of our drunken conversation was that we started getting into Erlang. I mean, are there any gory details that you'd like to embellish upon as far as the evening's events go?
No, as I said, my memory is probably more lavish than yours. The guys definitely had guns, the people on the train definitely had knives, and the guy didn't just have an orange bandana, he had an orange suit on, but I could be exaggerating there a little bit, but I think you get the gist of the evening.
I did also notice he had a couple of fingers missing, which worried me a tad.
Yeah, and we had a kind of early dinner at America, so he tended to do that. So by the time we got back to Folsom, which is by the way, if you've heard the name, it's Folsom Jail, where Johnny Cash had that famous concert. So by the time we got there, it was still relatively early. It was still about 9 o'clock-ish, if I remember rightly. It was half 9. It was still early enough to go out and have a drink. And by that time, that's exactly what we wanted. And that alcohol seemed the right thing to do at that time.
Yep.
But for some reason, we decided not to talk about events and talk about technology, which shows you how sad Brett and I can be when we go out for a drink. And I was the director of strategy, so it was really, in my mind, what can I do to make the platform more attractive to people? And I've recently just read an article about Erlang, which kind of got us into that conversation. And Brett, if you want to take it from that point.
Yeah, so I'm going on the next slide. I'm also trying to get you back on video. So Chris and I were sort of sitting there drinking, and Chris was drinking beer, probably fairly wisely, and I was drinking wine.
Yeah, I remember that.
And we were sort of philosophizing, what can we do here, as Chris says, to improve the OpenVMS platform. One of the things we wanted to do was to get an AMQP implementation, Advanced Message Queuing Protocol implementation, up and running on OpenVMS. I'd previously looked at porting OpenAMQ, which was developed by iMatic. Some of you probably know Peter Hitchens from ZeroMQ fame, for example. So Peter and Martin Sustrick had created OpenAMQ, the first AMQP implementation. And I ported that to our OpenVMS operating system platform, but for various reasons that probably either Peter could tell you or I'll probably divulge over a few more beers. Peter at iMatix had pulled out of the AMQP working group, and that left us in a bit of a bind because, you know, we'd ported OpenAMQ to VMS and we thought, well, you know, engineering will support that and this is all well and good, and that will be really interesting to our OpenVMS financial services customers. We had a problem. We didn't have OpenAMQ anymore. There was no support for it. So I was telling Chris had read a little bit about Erlang, and I was telling Chris about this thing I discovered called RabbitMQ, which was another AMQP implementation. And Chris, essentially, as you do after you've had a few beers, or in my case wines, Chris basically dared me to port Erlang to OpenVMS. If I could do this, then that would mean we could run Rabbit. It would mean we could probably run other Erlang applications, which Chris, being Director of Strategy for the VMS platform, thought this was, you know, a pretty good idea. This would give us lots of cool stuff on the platform that would be of interest to customers. So, you know, the last point on the slide, you've had a few wines, how hard could it be? Well, Erlang, if you look at Beam and you look at the associated components of Erlang that go around it, the core piece of Erlang software comprises about 400,000 lines of C code. It's got C code, .c files, .header files, things like that. The OTP libraries themselves are about 2 million lines of code. Now, I mean, thankfully OTP, of course, is Erlang, so it's essentially portable, but what I should point out there is if you actually go and have a look through OTP, there are places in that code where it actually checks what platform it's running on, and it branches depending on what the platform is. So, you know, it's an appreciable code base, and it's not like business logic code. This is quite challenging code to deal with. It does lots of system-y cool stuff and fancy things. But, you know, undaunted, I've ported OpenAMQ and other open source software to VMS, so I thought, how hard can it be? Well, OpenVMS, if anyone here is familiar with it, is not at all Unix-like. Not at all. It's totally proprietary operating system, I think that's fair to say, Chris.
Very much so, yeah.
Yeah, and what I would say though is at least it does have a fairly standards compliant C compiler, C runtime library and so on and so forth. So in theory what I was trying to do should be possible. I've included a little photo here which unfortunately Chris can't see at the moment because the video is not coming through of me on holiday in Mallorca working on the port. With beer, yes, well you've got to have the key ingredients here, laptop, beer.
Who took the photo?
I'm not sure who took that photo. But yeah, needless to say it wasn't popular me working on software whilst on holiday, but never mind. Anyway, so the bottom line is I achieved it. It took a reasonable amount of time. But some of the key things that you sort of face, what I have to say is the Erlang code base, the C code and so forth, is actually really portable. The guys have done a nice job of writing it, but there are a lot of preprocessor directives in there. I mean, it's been ported to a lot of Unix platforms. There are subtle differences between those platforms. As far as VMS goes, the sorts of things I had to watch out for, if you're familiar with Unix and the Unix fork function, VMS has never had and will never have a Unix-like fork function. So you can't just go and sort of, you know, do a fork exec sequence on VMS. It does not work. Thankfully, there weren't too many of those, and it was possible to substitute in vfork exec. The only problem with doing that is you kind of end up with more processes lying around. It's not the same. Other sorts of things. I'm just going to go through some of these. There's probably not too much interest. But for example, on VMS, there are just silly little things like when you're dealing with sockets. Blocking and non-blocking. On most Unix platforms you can use the fcntl system call. On VMS you can't do that. Poll and select on VMS only work on sockets, they don't work on other types of file descriptors. So basically in total I found, I went through and had a bit of a check the other day before preparing the slide. I had to make about changes in 91 areas of the C code to port that code to VMS to run Erlang. So it's actually a reasonable amount of work. Most of those changes, I would say, were relatively minor, but kind of identifying them and then figuring out what you needed to do did take some time. So I've sort of said here it took several weeks on and off. It's probably several weeks of my effort, but probably over several elapsed months. And I do recall actually having a major breakthrough whilst drinking a can of Foster's. What I found now, of course, is having done it once, it's kind of quite easy. So, I mean, a few weeks ago I did Erlang 16a across the VMS in a matter of a few hours because I'm just replicating the changes I made on the original port, which was for 13a. Also, I've noted there in blue, for the RabbitMQ guys a while back, I did a quick and dirty port of Erlang to AIX. And we've got a team within HP who are very keen to run RabbitMQ on HPUX Itanium. And so I've also ported it across to HPUX Itanium for them. Probably the biggest challenge with all of these ports is actually not getting something going, but it's dealing with things like I've listed down the bottom here. One of the nasty ones is something like SMP support, because that's quite processor specific. And you quite often find yourself messing with some machine code and some fairly exotic looking bits and pieces. As far as the VMS port goes, it's all pretty much fine and dandy. But as I say, you know, unfortunately we're retiring the platform, so you could argue it's kind of not going to go any further wasted effort. But as I say, it was a fairly useful learning exercise. What I've got in the middle of that slide though is one of the things that I did to make my life as easy as possible as far as this port's concerned. As far as Erlang on VMS is concerned, it thinks that VMS is just another variant of Unix. So if you do something like OS:type, it's going to come back with Unix, OpenVMS. That meant that reduced hugely the amount of code changes I had to make to the OTP code itself. But there were some sort of changes to the OTP code that you just couldn't avoid. So for example, if you look here, so this would be, the file would be probably os.erl, I guess, you know, so if you wanted to run an operating system command, os:command, and then a string with what the command is and so forth, I needed to implement, you know, quite a new chunk of code essentially for VMS, and I needed to write, you know, a little piece of C code or whatever to actually perform the command on VMS and pipe the data back through Erlang. But for the most part, whilst there are 2 million lines of OTP code, the number of changes there are fairly minimal, to be honest. And I'll just quickly go through this and then Chris can do his bit about big data. I don't want to hold him up for dinner. But as I say, the whole object of the exercise here was to try and get RabbitMQ and AMQP implementation working on VMS. The slide's a bit blurry, but basically what this is a DCL, which is like the scripting language on VMS. It's like shell script, I suppose. For the startup script of Rabbit. Lots of command line arguments that as Erlang programmers you'll recognise. The annoying thing is on VMS, because it's not really, it's kind of a bit funny about case sensitivity. A lot of this stuff ends up being in double quotes. So it looks like a horrible pile of spaghetti, but the magical thing is it actually works. I've got this little thing in here, which is defining what's called a logical name, and the little blow up out the side there says you don't really want to know what this is for. The C runtime library on VMS, not all that thread safe at times. So including that little command in there actually tells the VMS C runtime library to be thread safe, which kind of stops a lot of things breaking. When you actually say run up something like RabbitMQ, this is where I mentioned before I couldn't do fork exec sequences, I had to do vfork. So this process down here, which is the RabbitMQ process, is actually Erlang exec. It's not beam running Rabbit. Beam running Rabbit is this sub-process. I can't just kind of, you know, start up this other process and have that one disappear into oblivion. It doesn't work. These other two processes would be like the inet, get host, or whatever it is, processes, and so forth. But that all worked rather well. And we can, I don't know, we can do probably around, if you look at Rabbit, performance is maybe about half of what I'd get on a comparable Linux system. A lot of that is, as I say, we haven't got the SMP support, and also I had to put in place some special functions to do things like poll and select around polling on sockets. We haven't got kernel poll and things like that, so it's a little bit slow. But it runs pretty well. Also managed to port most of React, which was the biggest challenge with React actually was not porting the Erlang code per se, it was actually dealing with things like LevelDB, which is written in C, Bitcask, again written in C, actually porting those components was the major challenge for something like React. Okay, so Chris, we're going to get on to you. Now you can't see, can you?
Well, I can see what's in front of me, but unfortunately that's not what you'll see.
Okay, well we'll just have to do this the hard way. So we've got your first slide up, which is the title.
Too big to ignore.
Yeah, it's the wow.
Right, good. So we're synced. Okay, so that's just kind of start us by. What I really want to do is just introduce VMS, so used to saying that. Introduce big data to probably some of you might experience of big data and analytics over the past year or so. There's been lots of people have heard about it, but actually most people commonly don't really understand what it is, why we're talking about it, what's involved. And one of the first things I noticed when we said we were going to do this presentation is one of your members declined to come and made a comment about something about I don't want to come and see marketing slides, something like that. Which I took up with the phone read up straight away and said, what the hell is going on here? In fairness, I did a presentation to the British Computer Society up in Glasgow last week, and I got a similar kind of comment that there's a perception that big data is a marketing exercise, and to a certain degree it is, except that most products in the world have a level of marketing, and certainly IT products seem to have more marketing than anyone else. And I know Brett's involved in cloud. Brett will remember 10 years ago or so, and I first got involved with cloud with HP, and cloud's evolved significantly away from what its original concept was, and most of that is to do with the marketing that people like Amazon and Google and Microsoft have carried out and kind of changed people's perceptions. So marketing is there, whether we like it or not, marketing is there. But underneath there is a genuine requirement for big data and analytics, and hopefully you'll kind of get that idea by the end of today. Next slide, please, Brett.
Sure thing. You're on to it. What's the problem?
What's the problem? So that's the problem. There's lots of data. And I don't know, I kind of work out what all those numbers are. So I'm in the petabytes at the moment because we just sold a system that's got a petabyte of data, and that's the first system I've ever, no, I didn't sell it. That's the first system I've been involved with, which has got that much storage. But if you look there, the CERN Large Hadron Collider is generating 1 petabyte of data per second. And funny enough, a meeting I had the other day with IBM was talking about Edinburgh University, and Peter Higgs, who the Higgs boson is named after, his name cropped up in the conversation because apparently they're going to create a Higgs something or other up here, and IBM are getting all excited about it because I think it involves money to IBM. If you then go and have a look at exabytes, what gets me, Brett's right, I've been talking to a lot of university people recently and a lot of kind of scientific people, and I'm well out of my league when I'm talking to them. But a lot of people have been talking, there's a lot of people involved with the square kilometre array. The square kilometre array is essentially a bunch of receivers, not telescopes anymore, in Australia and some in South Africa, covering, would you believe, a square kilometre or more. And they're essentially going to map out the universe as we see it. And they're getting back 1 exabyte of data per day. I mean, that's just a phenomenal amount. It's just unbelievable amount of data. Currently, the whole kind of internet only generates about 1 exabyte of data a day, and just the SCAR telescope's going to produce that. It's just a huge amount of data. People got really excited about this, what we're going to do about not just that data, because we know what we're going to do with the SCAR array, but what we do with all this other data that's being generated by mobiles, by social networks, just by all kinds of things. And I've got a slide later on which shows some drivers of why the internet's, why this data is being created. And people start to think what we do with this data. And quite often when I go to speak to people about big data, it's, well, we know we've got this data, but we're not quite sure what to do with it. I was at Rolls-Royce last week in Derby, the aero engine people, and they get lots of telemetric data from their engines. And what tickled me was that this guy was telling me, said, we monitor this data on a regular basis while the planes up in the air were one of the engines to see if there's going to be a problem. And I said, look, you know, I've flown a lot of miles, and I really have flown a lot of miles, same as Brett. And I said, I really don't want you to be monitoring things while I'm in the air to find out there's going to be a problem with the engine. I really want you to be able to tell me well in advance that there's possibly going to be a problem. In fact, I don't even want to know. You're going to fix it. I don't want to know. It's going to be transparent to me. And he said, oh, that would be interesting. I said, well, you've got all this data. You know, have you ever thought about doing any kind of predictive analytics on it? And they haven't. So that's the kind of conversations I get into. I think a lot of people have heard about big data. Everyone knows about the masses, or everyone is aware of all this masses of data that's around, both structured and unstructured, but they're not sure what to do. Next slide.
Yep. Okay. What is it?
What is it? Yes, that means I should get on the next slide, doesn't it? So this is all the kind of stuff I've had, and in the top right hand, I actually, in fairness, I actually used this slide when I did a presentation at PCS. So when I mentioned that comment about one of your colleagues, it's in the top right-hand side. With all due respect, I'm hoping to hear more about Erlang, less about marketing trends like big data. And yes, I understand. You know, I am, despite what I said, I did start off as the bill, but I'm more technically minded than possibly I'll let on. But there are marketing is part of our way of life nowadays, and especially in IT. There's a lot more marketing than probably we like to admit. And whereas, yes, there is a trend, there is actually something solid underneath that needs to be discussed. And these are other kind of comments I've heard about big data. I've got no idea what big data hasn't jumped the shark yet means. I probably came from South Africa or Australia. But no idea what one of these days I should find out. Next one.
Yep. Big data can be confusing.
Yeah, so just to kind of emphasize that point about the marketing, this was a study I picked up on. And it's not a huge study in the numbers of companies. There were 100 people of fairly significant companies, but it was carried out as part of BT, a well-known global company, and Experiton I've heard of before. So you know, it's a good research company, small research, cash, but there you go. You know, that's what we got. And what got to me is that 67% of the people agree that big data is marketing hype. Yet in the same group, 79% agree that big data is a new generation of database and analytics technology. So there's confusion, you know, yeah, it's hype, we think it's hype, but oh yeah, it's also a database, but actually big data isn't a database, but it uses database. It is a new generation of using database. So it's again this kind of confusion, and I'm hoping my job in this world is to try and take away the clouds and the mist and make some sense of this confusion. Next slide, Brent.
Okay, big data standard definition.
Right, so if anyone doesn't know what big data stands for, it's these three B's are the common definition. And it was this definition was coined by Doug Laney, who used to work for the Meta Group, and in 2001 came out with this definition. And he came out with this definition because he was noticing that the structure of data was changing, the amount of data was changing, the speed and the variety of data was changing, and a lot of this came around because of social networks. So he came out with these three Bs, which are the accepted standard definition. I think there's around about 16 Bs now, so I think analysts around the world or consultants like myself pick a B, you know, think of a word that starts with B and then stick it on. So we've got veracity, validity, value, which are all very valid attributes, but they are qualities. They're not defining qualities of data, they're aspirational qualities. You know, we all wish that the data we have was all valid, when it probably isn't. Whereas volume, velocity, and variety are defining qualities. My only comment on that is that the volume, the amount of data, when people talk about huge volumes, not every organization in the world has huge volumes. So I wouldn't say you necessarily need all three of those qualities to be a big data environment. You could have the variety. A lot of people got the variety of data, and quite a few got the velocity, not necessarily huge volumes of data. Next slide.
Yep. So you've got your hype curve.
Right, and I'm doing that, and I know it's Gartner called it a hypercycle, but they do bring this out on regular occasions. And the thing about Gartner, the one thing I do know about Gartner, having worked in HP for such a while, a lot of people around the world take notice of Gartner. Gartner is the lead analyst, and I don't care what anyone else says. So what they say, people will listen to. And if you notice that what they're saying is that big data is now just about at the peak of inflated expectations and just about to go into the trough of disillusionment, which I think are wonderful terms. The key element there, though, is that it's going to take the content is going to take 5 to 10 years before it gets to the plateau of productivity, which is when actually something becomes useful. I'm just looking for cloud there. Yeah, cloud's just down the trough of disillusionment at the moment, right. Brett. I thought I'd just give you a bit of a G up there.
Yeah, well, thanks, Chris.
Yeah, you're welcome. So I kind of disagree with that. I don't think it's going to take 5 to 10 years. I think it's probably going to take 2 to 3 years. I mean, we really are just on the cusp now, and people are starting to take on my experiences working with organisations. Big data really is starting to take off, and this whole concept about what do I do with this data is really starting to catch hold. Next slide.
Yeah, I love the hype kit, Chris. I remember the whole web services thing and so on and so forth. I noticed they're not even on there anymore. They must have become part of the mainstream,
Yeah, well, that's where you want to be. You want to be on the right-hand side of that, not the left, really.
All right.
So these are some of the drivers for big data, and I mentioned, yes, it is hype. But from a commercial perspective, what I mean by structural economic shifts, that 10, 20 years ago, businesses tend to be bricks and mortar. They were the assets of the company and the product. Nowadays, there's a lot of businesses carried out electronically. A lot of companies don't have the bricks and mortar that they used to have, and a lot of the assets are IP. So there's a lot more data going around rather than bricks and mortar. A lot of assets of companies are based on data and IP. And when I talk about compliance and globalization, I talk about things like HIPAA. So I used to live in the States, and I used to deal with a number of healthcare organizations in the States, companies like GE and Cerner. And the HIPAA regulations came out, which meant that really healthcare organizations in the States, and then it kind of grew out worldwide, had to start keeping records on absolutely everything. So data just expanded in terms of how much they had to store. And I mean, legally, you always have to have accounting data. I'm involved with a company. We're doing a potential scanning project, and by scanners, I'm talking about medical scanners. They have to keep the data. That's got to be ordered. So data is being kept all over the place. So there's a lot of commercial pressures to hold more data. So there's just more data being created. And that takes me on the economic. It's just a ton more data being created nowadays. We're creating, what I say, an exabyte a day across the internet. So it's just huge. I think it's at the 2.5 exabytes in a couple of days now. It's just huge amounts of data are being created. But interestingly, the hardware and the software to actually deal with that data is getting cheaper. As the data gets more, the storage is becoming, it costs buttons now. I've got a great slide, I'll send it to Brett one of these days, or a great picture of a disk. It was an I think it was an RPO2 disk, many moons ago, a digital it was like 10 megabytes and costs thousands and thousands of pounds. And it compared that to a USB drive, 16 gigabyte USB drive for a few dollars. And the comparison was absolutely staggering when I saw it that way. And software, a lot of the software now to actually store and analyze this data is open source software. So Hadoop is the well-known one. There's lots of other bits of software as well. So the actual tools to do anything with this data are actually becoming a lot cheaper. And the supply and demand of human resources. There's a lot of IT people coming out of India and China right now, a lot more than there is coming out of Europe and the US. And you will notice if I go on a lot of big data forums and I live in forums. And I would say 90% of the people who are active on these forums are educated and work in India. The one issue we've got there is that all the work demand tends to be in the Western Hemisphere and all the resources are in the Eastern Hemisphere. Now, I haven't quite worked that one out yet. But there is a lot of people coming on the market. There is a lot of drive to create these kind of IT sectors where they can work in. And that is, believe it or not, driving some of that as well. And then we get the technological, so the development community, people like yourselves, you're now on the open source community is driving big data. So yes, there is marketing hype, but actually there's a lot of development coming from developers, believe it or not. And that really is driving it, driving momentum. And then we're starting to get situations where people have started to come up with use cases of how to use big data. Because previously, as I mentioned before, people were kind of scratching their heads and saying, well, we don't understand, what do we do with it? And we're now coming out with use cases, some decent use cases of how to use it in case studies. We've got new tools coming out regularly. Device mobility and cloud apps. So there's, every time someone brings out a new cloud app or mobile device app, there's just more data being generated. It's just incredible amounts of data. And then the expanding Hadoop ecosystem, which is, of course, linked in with the open source. I've been involved with many open source projects in my life, and I've never seen one with a life and momentum the way Hadoop, apart from Linux. But never seen one like Hadoop that really is got a life of its own and really taking off to the point where Hadoop is becoming synonymous with big data. And actually, I'm going to get onto a couple of slides to say, well, that's not actually the case. You don't need Hadoop to have a big data environment. It is what's considered the standard. It's not absolutely necessary. So next slide.
Okay, it's a nice little cartoon, which I remember.
There's a nice little cartoon, which I thought cut in with. It's not the only one I could find that had Erlang and big data in the same sentence. So I thought I'd throw that up. But again, we're starting to move in. What relevance has Erlang got in the big data world? And fault tolerance. Because one of the big... I was with VMS for 11 years, and Brett knows VMS, and I don't know if anyone in the audience knows VMS. When we talk about disaster tolerance, not fault tolerance. And we were quite arrogant because we invented, as far as we were concerned, we invented disaster tolerance. No one can tell us anything about tolerance. And fault tolerance was, well, that's just because you can't do disaster tolerance. So I've kind of grown up with this. And but Hadoop does provide a fault tolerant, a very strong fault tolerant situation by replication and distribution. The sad thing about it, I never mention this when I'm talking to people, is that because most of the servers in any Hadoop environment are all on the same data center, it's not particularly disaster tolerant, and you could lose it with one explosion or one fire or one anything. But I don't mention that to people because that wouldn't be nice at all. Next one, please.
Yep. Okay. So this is
what I did. Sorry, Brett, you want to say something?
No, it's just I'm just not sure what you're looking at. So no, far away, Chris.
On the first book sense screen.
Yep.
Right. So what I did, I wanted to find an example of where Erlang is used in a kind of big data environment, and there's not many around, or certainly not many that's publicized. And I think that's because of the early adoption of big data, and B, people see Hadoop as being the answer to everything when it isn't necessarily so. But I did come across, and I'm sure you guys, a lot of you guys will probably know this, but I did come across this example of a company called BugSense in the US, in California, where they do, basically they monitor metrics on mobile apps, and they have to create their own current big data environment, and it's real-time data as well, so they're bringing in real-time data, and they didn't adopt a Hadoop environment. And I'm thinking, I don't know why they did, but I'm thinking probably they wanted to do their own thing. They were developers, they're in California. Brett and I have got a lot of experience with people in Silicon Valley, and they always tend to do what they want to do, not necessarily what anyone else does. There's a very strong not invented here culture in California. So I suspect they just want to do create their own infrastructure, or maybe use an existing infrastructure and expand upon that. But anyway, next slide, Brett.
Yep. We're there.
They decided to, so that was the problem. They had, they wanted to have an awful lot of data, an awful lot of requests. They had a file that had 125 million rows, they wanted to join all these things. And they didn't want to spend a huge portion on servers. So one of the drawbacks with Hadoop is it does dictate that you use an awful lot more servers than you probably need. So what they did, they built a number of instances running on Azure, which is Microsoft's cloud environment, and then probably put them into an in-memory database. And they were quite clever for what they did. But they used Erlang for communication between the nodes. So when they were looking for messaging transport to be able to, for their fault-tolerant environment, they actually did, they brought Erlang in, as I said, kind of encoded with themselves rather than going with anything else that was already there. if we go to the next slide, which is the architecture slide, it shows you how to do this.
Yeah, I mean, I've got a few comments on the Bugsnax project later on, Chris, but...
By all means, jump in now, Brett.
Yeah, well, no, I'll leave it till then, but I mean, I think it's a good example of where Erlang fits quite nicely in this space. In terms, you've mentioned fault tolerance already, but in terms of the concurrency and the ability to sort of basically cluster things together. You know, you talk about fault tolerance. I mean, there are customers out there running React on 80 or 90 nodes. You know, if 40 or 50 of them blew up in a puff of smoke, you're probably not going to lose any data. Things might not run all that well necessarily, but it's kind of going to cope with the situation. And these are the sorts of things that, you know, the audience here are aware that Erlang just provides out of the box. So it's kind of logical in terms of what the Bugsnax guys did in terms of how they leveraged Erlang.
Yeah, I quite like the architecture. I think it's very simplistic in what it does, but actually does the job. One of the issues I've got, obviously working very close with IBM. IBM want me to sell, not want me. It's because we're their partner. We push IBM products, and IBM have their own version of Hadoop, which is called Big Insights. And of course, you pay for that, you pay for the support, you pay for maintenance, you pay for all that stuff, which is great. What I'd rather have is a more open conversation, and where there isn't someone from IBM keeping over my shoulder, I'll have that saying, you don't necessarily need all that complexity, because Hadoop, for all it's very good, it's actually raised attention to big data. It's a very generic type of solution, and it's not necessarily scalable in the way people want to use it. You really need a lot of stuff in it. You need a lot of servers and all kinds of stuff, and it isn't really scalable at the lower end, and it really isn't focused quite often on what you want to do. So a roll your own solution, which this one is, in many cases, it's going to be the better solution. Right. It's going to be more focused, it's going to be faster, it's going to be something that you understand. It's not necessarily just going to have the kind of generic environment that Hadoop gives you. So I think this is a really good, relatively simplistic example of what you can do with the right products in the right space. Now, saying all that, you do need to know what you're doing with this. It's not just the amateur can come and do this. Yeah, I quite like it. Anything else I'd like to say on that, Brett?
Well, yes and no. It's probably just something that's come out of the conversations I've had with customers in the past few weeks, where, you know, I've been talking to customers about how to get off of OpenVMS and all of this sort of thing. And obviously one of the targets is to try and leverage open source, which you know, these guys are doing here, and Erlang is also open source technology. But basically, we've sort of got into conversations with customers about developing software from the ground up, you know, writing all the code. And I'm sort of saying, well, no, it's more about, you know, finding the building blocks and sticking them together.
I wasn't disagreeing with that, Brett. What I was saying is that the Hadoop environment, which is the major player in the space, comes with a set of building blocks, and you could quite possibly get your own building blocks and put it together better than Hadoop to suit your environment.
Exactly, and I think we're on the same wavelength, you know, with what the guys at Bugsnax have done here in the example you put up, is that they've gone out and they've glued together some open source building blocks in a pretty neat, effective way.
Yeah. No, I think we've done a good job.
Yep.
Right, move on to the next one.
Yep.
I just want to go through a couple of examples now. Brett asked me to throw some examples in. People I've been talking to. Now, I've kind of this isn't a sales pitch. I'm just going to talk about some of the things we're doing, and I've kept the company names out of it. And one of the companies we're working with, I mentioned before, do medical imaging, and that's MRI scanners, X-ray scanners, all that kind of stuff, CT scanners. And what they do, there's a legal requirement in the UK to have these devices audited on a regular basis once every year, so they have to keep data. All these scanners produce tons and tons of data. And the guy who runs this company came to us and said, we think it might be a good idea to do something with this data, because there's no standardization in the UK. A conversation I had with him about a couple of radiologists that he knows using MRI scanners, and he was saying that for a particular process, and I can't remember which one it was, but you know, having a look at someone's right wrist or something, He knows one particular radiologist who could do it in a minute, and he knows another one does exactly the same process and takes him 10 minutes. He says there's no standardization on this. There's no level of quality particularly on this. So, you know, there isn't any process in place where the NHS in this particular area said you've got to achieve a certain standard. He said there's just no standardization. And on top of that, there's just no one using the data. So they get all this data off, which is pretty interesting when you have a look at it. And then we do an order, we write a report on it, and then the data's lost, we don't do anything with it. So what he wanted to do was bring some kind of standardization to the UK eventually on the way scans are done. And he said in this way, we'll get a level of quality across scan and medical imaging. And also, if we can cut down the use on certain things, because, you know, some of the bulbs that they use in these scanners are extremely expensive, cost thousands of pounds. So he said, if they're doing a particular scan and they're doing it for 10 minutes, it really only needs to take 1 minute, then that's 9 minutes more use of the bulb than they need to have. If we can cut down the usage, we can save money. But the bigger one, from our perspective, is that if we can take this imaging database and start getting, get some insight out of it, combine it with, and we're just throwing ideas out at the moment, weather information, other environmental information, other medical information, and start trying to get some insights out of that so we can start to determine if there's particular areas where certain conditions or diseases are more prevalent because of, I don't know, the wind direction or some environmental thing about it. We don't know. The problem is with this kind of stuff, we don't know why you don't know. But we want to pull the data together and stick it in some repository and then do some analytics on it. So that's quite an interesting little project there. Next one, Brett.
Yep, genome.
Yeah, and Brett mentioned before, I'm getting involved in lots of things at universities, and this is a major UK research university, and they're building a centre of computational research. Currently, they've got a couple of genome sequences which output 2.4 terabytes of raw data a week, so that's nearly 5 terabytes of data, raw data a week are coming out of these things, and they kind of hold, they normalize the data, hold it for 3 months, and then throw it away. So I'm talking to the professor who's leading this this whole process, and at the moment he knows he's got lots of data, not only from his own researchers, but they're also linked to other researchers around the world. Particularly, he mentioned the University of China, which apparently has hundreds of sequences. So what he wants to do is try to combine all this genome research, and again start getting some insightful information out there. There's no more questions we're going to ask yet. But he knows that he wants to ask questions, so I'm working with him how we can create this environment, create this repository, and do some kind of analytics. The one problem I've got with this is that the IT people involved, they want the data to be centralized for IT purposes, so they can back it up and archive and do all those good things. So we've got a little bit of a discussion going on there right now. But just while we're on the genome thing, I'm actually, I've got a meeting in Manchester on Monday with the UK Cancer Research, and they're also doing genome research in a different area. They're doing medical. This one I mentioned on the university is more environmental. So I'm starting, because there's lots of data around these genome sequences, and people don't really know what to do. They do and they don't. They do certain things with the UK Cancer Research. They run certain bits of software. You know, this guy thinking, can we run more stuff? And again, I think the combination of different types of data might give us an idea. It would, for me personally, and this is an absolute dream, it would be fantastic if we could do something and in some way go towards developing a cure for some kind of cancer. I think that would be such a fabulous effort to be involved with. So we're very early stages on that one, so we'll see what happens with that. Next one, sir.
Cool. Yep. Predictive maintenance.
So yeah, I spent some time with a large UK manufacturing company. I mentioned it before that did aerospace engines, and we didn't know what was. They couldn't predict anything. They could do the, we could tell your engine's going to fail in about 5 seconds, which I really don't want to hear about. But they couldn't predict anything. I'm going to put together a proposal which will say, well, potentially, if we've got good enough data and good enough historical data, which he says we can get, we can potentially start predicting, 6 months ahead that you might have a problem with particular engines in this particular area. And that's the kind of thing you do with predictive analytics. And the guy got all really excited because they spend lots of money, I won't tell you how much, but lots of money on maintaining engines and keeping levels of spare parts and resources around the world. He was getting really excited if he could save some of that money. And I was getting really excited if I could stop planes falling out of the air in particular moments. Which again, Brett and I'm sure Brett, I'll have to leave with Brett and tell you later on some of the journeys we made. So that was very close to our hearts. Planes falling out of the sky and crushing and doing things like that. Not that we've been involved in the planes falling out of the sky, but we do know all these things. So that would be very close to my heart. Yeah. So there's just some examples of the things I'm getting involved with now. And these particular ones, they all involve lots of data, lots of kind of raw data that needs normalized and putting in some kind of sense. But some of the other projects I'm getting involved with, it's more the variety and the velocity of data than sheer volume of data. So I think they've all got a part to play in big data environments. And the last slide says?
Last slide says, big fat guy.
You're not just a buzzword. And that's hopefully, when you come away from this today, you'll realise that big data is not just a buzzword. And there is something solid behind it, and there is a part to play for Erlang as well. So, that's the end of my bit, Brett.
Okay, thanks, Chris. Excellent. Well, I've just got a few slides to sort of finish off, and then I guess people can ask questions. But you've already talked about the bug sense as an example of where Erlang's being used for what is arguably a big data type scenario. We've talked about, the capabilities of Erlang, fault tolerance, concurrency, distributed processing, and so on and so forth. Like you, I found a few projects. I've got one up here on the screen at the moment called the Disco Project, and I'm having flashbacks to the late 1970s, which I'd rather not. I've got Bee Gees tunes running through my head. Donna Summer, all that good stuff. I've got to stop.
Oh, now that's what you do want to keep.
Yeah, well, no. Anyway, Yvonne Elliman, that was my favourite, but there you go. Anyway, but there are some kind of themes that came out here, but just while you were talking, one of the things I sort of thought about was really, it's like the guys here today who are staunch Erlang programmers who do a lot of good stuff with the language. What you're doing, there's a lot of incredibly fascinating stuff there, and I think the world's your oyster. If you're an Erlang developer, you've got the right tools to do some pretty darn good stuff in this space. And there are a small number of organisations, Bug Sense that Chris mentioned, Disco Project that I've got here. There's some kind of commonality coming through. In the case of Bug Sense, they've got Lisp in there. And if you look at the Disco Project, if you're familiar with React, you write queries in React in like JavaScript or in Erlang. The Disco Project, which is basically a MapReduce environment, essentially you write your MapReduce functions, the things you want to do with your data and so on and so forth. You write them, in Python, which probably is a bit simpler to many developers than writing something in Erlang. But it's a similar...
Just to point out, Brett, that MapReduce is one of the two really key elements of Hadoop.
Right, exactly. So, technologies like the Disco Project I've got here, like React and so forth, that fully support MapReduce in all its glory, and provide some sort of simplified mechanism for developers. Python intrigues me. As I say, I work for HP Cloud, which is based on OpenStack. And a lot of what goes on, all the orchestration and so on and so forth with an OpenStack is all written in Python. And I chuckled, my friend Peter Hitchens, 0AQ, OpenAMQ, I was talking to Peter about this in Python, and Peter just goes, Python, the basic of the cloud. which kind of amused me, and I do enjoy sort of telling that to our Python developers that work in HP Cloud. But the Disco project is a good example, I think, of a big data project that's using Erlang, and some others have started to expand on this, and they've done talks at Erlang factories and so on and so forth. I'm not sure about dancing with big data and the Disco Inferno. I think they need to draw a line under the analogy with Disco, because it just really bugs the hell out of me. Chris has already talked about the bug seeds project, which I think is another really good example of where Erlang is being used in the big data space, in-memory database, and doing some cool stuff with that. As I say, using something like Lisp in the place of, say, Python or JavaScript in the case of React and Disco for implementing your queries and so forth. Similar sorts of concepts coming through. Some other interesting ones I found. I mean, let's not ignore React, of course, which is a fine product. I absolutely just love it. I've been sort of touting React's virtues to customers around Europe as I've been travelling around over the past 2 weeks. I've sort of been saying, Chris, that in terms of like, VMS is known for its fault tolerance and so on and so forth. I think React is easily in the same league. If you want to store a lot of data in a NoSQL database, a very sophisticated key value store, something like React is just about impossible to break.
I need to learn more about that because I see that as a very valid alternative to something like HBase again within Hadoop.
Exactly.
So it is something I really need to look at.
And we've talked, and it's a shame we can't be here to talk to the guys really about the NHS opportunity. I think it's the Spine application. Which is a really nice win for the React guys. The Basho guys also uses Rabbit, which of course is another Erlang-based application. So it's really good to see, something like NHS, which we almost consider the last bastion of non-open source, actually going for something here, which is essentially a totally open source-based solution.
I'm sure we'll have the conversations later. At least I hope we will.
Yeah. Some other ones I've got there. A company, I think they're based in Germany, but don't quote me on it, Game Analytics. Developing what I think it probably fits into the big data. Chris has talked about those V's and so forth. In the case of what Game Analytics are doing, you've probably got more of the velocity carry-on going on with the streaming there, streaming analytical engine. I put VaultDB up there. VaultDB is actually implemented in Java predominantly, although the kernel is written in C. And it's probably more transaction processing in this particular example than big data. But it's interesting here, leveraging the capabilities of Erlang in terms of concurrency and so forth to achieve some pretty fantastic transaction rates. And well, they got their 877,000 TPS. That's a fairly spectacular number. As I say, maybe not so much big data, but as opposed to OLTP, but interesting nonetheless. One last thing I wanted to mention about big data really is the Internet of Things. Now, the Cisco CEO recently, I saw in the news, was sort of saying that the Internet of Things, connecting your fridge and other household appliances and just about everything else into the Internet. He's quoted as saying that that's a $19 trillion opportunity. Well, that sort of number is kind of silly and it's probably not right, but in any context, the Internet of Things as far as vendors like HP, as far as Chris is concerned, as far as Cisco is concerned, it's a big business opportunity. The Internet of Things is going to happen. We're going to be more and more connected. It's not just about you interacting with your friends and so on and so forth. It's about your home, your car, anything else being hooked into the Internet and information being exchanged in various forms. It's all going to come down to big data, and I agree with Chris totally about the Gartner hype curve. I think things are going to move a hell of a lot faster there than what Gartner maybe suggested. And there's a lot of opportunity, I believe, for languages such as Erlang in that space. Up to you guys to make it happen. In summary, and Chris can do a bit of a summary here as well. This is sort of quoting some stuff that Chris has said, really, I guess, that big data is really about extracting value from data. It's not necessarily about how much data you've got. It's about extracting the data from the value from that data, doing it in a timely fashion. You've got a lot of information lying around the place, getting the most out of it. Okay? It's not about how much data you've got. Erlang, I think, is a very powerful tool in this space. We've talked about distributed processing, we've talked about concurrency, so on and so forth. I had a bit of a spiel at the start of the talk about porting Erlang to alien platforms. Good introduction for me to the Erlang programming language. It probably means whether I like it or not, but I know more than I care to think about the internals and how things like Beam works. Arguably that's useful for something or other. Fascinating exercise and absolutely wonderful spending time with Chris talking about these sorts of things. Final comment that Chris made, which unfortunately you couldn't see but was in the notes to his slides as well, is it doesn't matter how bad your day has been, which our day was pretty bad back in November 2008. Good things can happen with the addition of a little alcohol and the company of a good friend. Over to you, Chris, to wrap up.
Well, I'm glad you included that because I think it's very true. Just the last point I'd like to make that you said, Brett, was the Internet of Things, and I think that's absolutely key. We're seeing all kinds of devices being connected, being connected now, especially with the hardware device AV6, so they get more aggressive. The more things we get connected, the more data there is, the more people are going to want to analyze it and have a look at it. So the bigger the kind of opportunity there is for Erlang and developers. One of the things I do, I work quite closely with the university in the UK, there's Sheffield Hallam University, and I've got access to 4 of their postgrad students, and we're going to get one of them within the next month or so. There's going to be a software stack which competes with Hadoop. So I think like Erlang, things like Lisp, React was one of the areas I wanted to look at for the databases, the replacement base. So I'm going to kind of build that in because I do see that's got a great future as well as environments like Hadoop. So just bear that in mind, guys, when you're going out there. These things are going to happen. It's going to happen probably sooner than, well, it's going to happen sooner than God, I think. And there's going to be a great opportunity there. And once again, thanks very much for the opportunity to talk to you. I'm really sorry I can't be there and share the beer with Brett and the pizza with you. But thanks for the opportunity, and I hope it was worthwhile for you.
Okay, well look, we'll maybe take a few questions. I mean, I don't want to hold you up, Chris. I mean, we're between you and dinner and a beer.
Very much so, Brett. Yeah.
So maybe we'll just keep it short. I mean, if anyone's got any questions for Chris, we'll take them now, and then Stephen can do a wrap-up, and we can polish off the pizza and the beer. Yep.
So I've got some general questions. If I'm looking at kind of processing petabyte data stores, I would get very nervous about being able to do that on a cluster with Erlang. In terms of my experience of it as handling raw data is nowhere near what I see in the big data clusters I'm familiar with.
Okay. I'm not sure if you heard the question, Chris, but
I did. I just heard the bubbles.
Yeah. It's really about, you know, if you're wanting to process petabytes of data and you know, in some sort of cluster and using Erlang to kind of do that. I think if you look at solutions like the ones we had up there, the Disco project, BugSense, and even if you look at things like React, it's not entirely Erlang. And this is what I come back to before about plug and play with regards to open source technologies. You're not necessarily just going out and grabbing one thing. You're grabbing a pile of building blocks and gluing them together. And what Erlang, I think, is really good for is things like the distributed processing, concurrency, fault tolerance, things like that. But if you look at, say, something like React under the hood, in terms of the data storage, Bitcask, LevelDB, these are things that are written in C and so on and so forth.
I mean, that's what I'm finding I'm having to do, is use Erlang for a control flag.
Yep.
And drop down.
Yep.
Because I find that communication into Erlang is bottlenecked.
Right. Well,
I can't get data in and out of Erlang.
You probably need to talk to Stephen here about getting some consultancy services to address that problem. But you know, I think the point remains: it's not you're not going to have a 100% Erlang solution from top to bottom. I mean, end of story. It's about identifying the right building blocks and gluing them together in the right way.
What I would like to see is somebody doing something like Erlang support for RDMA, things like those technologies, which is what we use in the large clusters.
Any thoughts on that? That's an interesting notion.
Well, it is, and I think that if Francesco were here, he'd sort of come out with a mantra that Erlang is the right tool for the right job, but it does begin and end there. And if you think right back to its its invention, it was the control plane for a telephone exchange, and there was a lot of other code that it was actually looking after. And I think that is its sweet spot. That's what it's very good at. It's very good at managing and organising. But as you say, there are other components and other bits and pieces that you have to blend it into. And I think what you've just come up with is probably a very good argument for saying, well, put it forward to the OTP team.
Yep.
Put it on the message stand.
The trouble is they're still very much focused on building small systems to go in that's the history, and that's very much their sweet spot. They're not looking at all at improving Erlang for this space.
Yeah.
It's an interesting point. I don't know. It's maybe supply and demand. I suppose it's people like Chris as well getting out there, and it's interesting, as Chris says, about the access he has to postgraduate places like Sheffield University and so on and so forth. And I mean, a lot of this industry, to be honest, is about joining the dots. I mean, Chris was talking about Gino. Chris was talking to our old friend Gerrit Wertman, right, and from the Netherlands. And Gerrit has taken early retirement from HP and has become like essentially a DNA detective. You know, if you're not sure, is that person really my father? Then Gerrit will go out and research it. He has a background in the space, theoretical chemistry, biochemistry and things like that. But, and he was explaining to me about all these sorts of projects where, I wouldn't say they're public domain or whatever, but it kind of reminded me of what's that project, where there's that search for extraterrestrial life and you can fire it up on your laptop.
SETI.
Yeah, SETI, that's right. It kind of sounded a bit like that, where anybody can get involved in this stuff, Chris, you know. And a lot of it is just about joining the dots, making sure the right people are talking to each other and making it happen. You know, so...
in this field more so than anything else, because most people don't know how to put a solution together, or don't know what they're looking for. So they're looking for advice and they're looking for skills. And if someone can come up and say, well, this is what we think you should do, this, ooh, that's very good. Why don't we do that? So you're absolutely right, join the dots.
Yeah.
I'm going to try to answer this question because, sorry for my English.
So you made up here, that's good stuff.
If you, I'm trying to answer the question. If you look at the high frequency trading software, it's not written in Erlang, nothing like that. It's written in C++. So if you need real time, you write in C++. If you need fault tolerance and have high availability, you use Erlang.
Yeah.
Simple as that.
So again, the hybrid solution approach using...
That's right, but I mean, I do that today, but it just... It takes a lot of time, and if I can write it all in Erlang, then it's much quicker.
Yeah.
It's much quicker to write it.
The only thing I'd say about that is that you're not alone in sort of expressing the desire, and although it may not be apparent, there is a sort of groundswell of people trying to put more pressure on Ericsson to be a bit more open-minded on that front. I think the sort of manifestation of this is the Industrial Erlang User Group, which is the body that funds, I think, is Erlang Central, which does include Ericsson. But I mean, it also includes Klarna. I'm trying to think of other names, probably AOL. Some larger corporations who've got a vested interest in trying to widen, if you like, the horizons of Ericsson. And that probably not something you want to hear, but Ericsson, I think it was last week or so, invested in something that we've been working on for quite a long time with Adaptiva in the Parallel. And we've had part of our embedded systems with Kent University here, with OMA, working as part of the KTP. We've done a lot of work and development on that in the Raspberry Pi, and now Ericsson, and along with others, have come up with the second round of funding, I think it is, for Adaptiva, to put some real clout behind the development and the distribution of that board. Unfortunately, again, it's at the lower level rather than at the high level.
No, I think there's a problem to solve there, which is the number of nodes. At the moment, you're very constrained about building a large Erlang cluster. It's too chatty. You can't.
It's too much time.
You can't go to thousands.
Well, I'll tell you what,
thousands of nodes. I have in a big science cluster.
Okay. Well, we'll let Chris go and have his dinner, and we can have a chat over a beer and pizza.
You should have
Yeah, if you don't mind, I'm sorry guys.
No, not a problem, Chris.
Don't mind.
I mean, thanks very much for the time, Chris. I think it's been much appreciated.
No, my pleasure, Ben. We'll catch up tomorrow.
Okay, talk to you soon. Bye now.
Cheers, everybody. Bye.
There is another guy that you have some synergy with. I'm not quite sure what he's up to now. He had I'm not sure, massive systems or massive computer systems. They used to be based out of Malta. They're actually Slovenian or something. but they did the control software for Lomonosov or something, which was Moscow University massive HPC installation, at one time the largest in the world. And he had exactly the same problem as you, but he stripped out the TCP communications from the Erlang shell to avoid a lot of the unnecessary messaging, so they could control this stuff in a manner that was timely to actually manage the cores of the system. So there are people that go and do it, but the danger, as you say, at the moment is you end up pretty much out on the limb, so you've got a lot of work to do to keep up to speed.
I mean, that being said, you know, the community can influence considerable change.
Yeah. Well, and it does, in fairness. I mean, I can't remember the committee, but Eric Stemmer, and what's the other guy name from Ericsson? His name will come back to me. But they are an open committee. You can write to them and tell them, and they go through, sometimes in public, a list of, well, these are the things that we want to put on. Let's put a priority to them, and let's see whether we agree to do them. It is reasonably open, but as I say, the industrial user group is there to try and force, and at some stage it may well create a separate branch that's in addition to whatever Ericsson produced.
But yes, I do hear what you're saying about the chattiness in clusters. I mean, I use Revlink here a lot, and I know exactly what you mean. Yeah. I might actually look into that when I get back home. Make some changes and see what we can do.
Well, thank you.
But any other questions, then Stephen can do a wrap up.
So is there a built-in database in OTP? There's that database as well.
Yes. Well, you've
How
got.
does it scale?
Well, okay. So Amnesia would be the distributed built-in database within Erlang. How does that scale? Well, my answer would be reasonably well. But I think it's kind of a self-answering question if you look at, say, products like React and so forth, that they haven't taken that route, where they've looked at providing alternative back-end data stores and so forth. So, for example, something like RabbitMQ uses Amnesia for its configuration data and things like that, and that's great because when you create a clustered Rabbit, the data is automatically replicated, certain controls around that, and that works fine. As to whether I would take it to the sorts of scales that Chris is talking about, no, that's not what it's designed for.
That's the issue. I mean, I was talking to somebody yesterday and they said exactly the same thing. They've gone ahead and done pretty much what you said, built their own control mechanism using Erlang, but they said their criticism or their problem that they had spent a lot of time overcoming was that if you then made it distributed, and in general terms they meant cross-continent distributed, and there was a split of some description, it took a very long time, it was very complicated to recover it.
Yeah.
And for exactly that reason, I'm sure that's why React doesn't use
Indonesia, I find, is good for lots of small tables.
Yes.
Doesn't like big tables.
Yep.
That would be
Lots of
true.
Small tables, great.
That would be true. And if you look at React, you've got a multitude of different back ends. You've got a multitude of different back ends, and one of them, which is an in-memory option, is basically using native Erlang components. But of course, as soon as you start talking in memory, then you're constrained in terms of just how big you can go in terms of your data. So yeah.
So I'd just like to add that really you need to understand your data model first, because that's going to drive your data store solution.
Exactly.
It's going to be optimal for what you're trying to do.
So even the choice of backend for React, whether you use, for example, Flipcast or LevelDB, is going to depend exactly on like Brendan said, on what your data looks like and how you are going to start interrogating it and using it.
Sure. Well, it comes to me, it looks like there's very little pizza left, unfortunately. I know you'd like to finish it off. Thanks very much, Brett and Chris, for the talk. It's been very interesting. It's good to hear some questions. Thank you all for coming. You're always welcome whenever we hold these events. Some are more open than others. I think it was quite interesting to hear some sort of otherworldly and external type talk rather than people pressing ahead with the mantra that Erlang is the solution to everything. So, it's a practical world, and as you say, people use the right thing and for the right solution for that particular problem. That's probably what we're